In this video, we are going to look at central limit theorem and how we can implement it using random data. By definition, central limit theorem states that the sampling distribution of sample means approaches a normal distribution irrespective of the population distribution. The two main properties that we are going to implement here are the means of the sample data approximates mean of the population, and the standard deviation of a sample approximates standard deviation of the population divided by the square root of the sample size. So we are going to use Python, and here I'm importing all the libraries, and we are going to create random data. So I'm going to pick numbers from 0 to 100, and we are going to pick 1000 such numbers. So this is going to be our data set. And to check the distribution of our data, I'm going to use Seaborn. So the histogram plot looks something like this, which is not normally distributed. All right. Next, what we are going to do is we are going to create 50 samples, of each sample being of size 1 5 15, and we are going to create a sample list. So to do this, I'm going to iterate, and I'm going to take 15 random numbers from our data set, and going to append it here. So when I do that, this is what we are going to get. So here I have 50 samples, each of size 15. Okay. Next would be we are going to calculate the means of each of these 50 samples that we have taken. So when I do that, I'm going to put that into the sample means array. So when I do that, for each of the 15 data points that we had taken samples, we have got the mean of it. So for the first 15 numbers, the mean would be that the mean is 31.666. Similarly, for all the 50 points, we have done that. All right. Now what we are going to do is we are going to take the mean of all the means that we have taken. So we have 50 means or averages of the sample data, and the mean of that would be 50.03. So I've put that into a variable called mean of the means. All right. Now this is where we are going to check whether this mean is actually approximating to the actual population mean. So the mean of means is 50. And now, since our data is small, we can actually calculate the original mean as well. So the original mean is 49.2, all right, and the one that we got is 50.0032 of this mean of the means of the sampling data. So we can calculate the population mean without actually calculating the entire mean of the population. We just have to take enough samples so that it approximates to the actual population mean, and that's what we have done here. Right. So if you see, the difference is 0.8, which is small, but if you increase the sample size, you will get you will go closer to 50. You'll go closer to 49.2. All right. The next part that we'll look at is the how our mean is normally distributed irrespective of their population distribution. So I've plotted it, and if you see, it is normally distributed, and the mean is 50. That is 50.032. And if we recall, we did not have the similar distribution on our original data. So we can say that the distribution of the mean follows a normal distribution irrespective of the nature of the population distribution. Right. So this is how we can prove central limit theorem actually works. Right. Let's talk about the standard deviation as well. So the standard deviation of a sample which we can calculate is nothing is equal to the standard deviation of the population divided by the square root sample size. Right. So in this case, we can calculate the standard deviation of the sample means, that is 7.42. And if we calculate the standard deviation of the original data, we get which is close to, which is 7. So it is, the difference is quite high, but you can actually increase the size, increase the sample mean, and you will go closer to your closer to the standard deviation, which is 7. Alright. So this is what the central limit theorem talks about, and we can prove this using some random data. So this is actually applicable to your original data as well if you have any real life data. So this is what I wanted to show you in this video. So thanks for watching. If you like the content, please like, share, and subscribe. Thank you.